Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are the Science and Technology. We're Backyard Musings Science Technology channel.
Yeah, and we're talking space today. So here we go.
Yep. Very interesting. Researchers have found a razor-thin rotating string of galaxies inside a massive cosmic filament. Massive. If galaxies are in it, it's got to be massive. Revealing unexpected alignments that challenge models of how galaxies gain their spin. And what you see on the screen right now, I guess, is cross sectionals. I mean, galaxies are huge. So this is like a micro look at something huge. You can see the galaxies inside of this filament thing. I mean, after we go to heaven, we'll find out how all this is created. But let me assure you, Heavenly Father knows how to create this stuff. Okay. An international
unlike Congress creating a bill and then not telling us until they read it, until they pass it.
If you want to know what's in there, just pass the bill and then you can read it.
Right.
An international research group led by the University of Oxford has uncovered one of the most extensive rotating structures ever documented. A razor-thin chain of galaxies positioned within a massive spinning cosmic filament located 140 million light years from Earth. Now, that's not far. We can reach out and see 200 million light years away with our James Webb telescope. The discovery, reported in the monthly notices of the Royal Astronomical Society on December 4, 2025, helped clarify how galaxies first developed in the early universe. Would you like to know more?
Cosmic filaments represent the largest structural features known in the universe. They consist of enormous thread-like networks made of galaxies and dark matter that create a kind of cosmic framework. These structures also guide matter and momentum towards galaxies in their vicinity.
When nearby filaments host numerous galaxies that rotate in the same direction, and when the entire filament appears to turn as a whole, they provide rare opportunities to examine how galaxies acquired their present-day rotation and gas content. I'm thinking mass. They rotate because of mass. If you have mass, you're going to rotate. They also allow scientists to test ideas about how large-scale cosmic rotation forms over tens of millions of light years.
In the new research, scientists identified 14 hydrogen-rich galaxies arranged in a narrow, elongated formation measuring about 5.5 million light years in length and 117,000 light years in width. That's big. This slim arrangement lies within a much larger filament that stretches roughly 50 million light years and hosts more than 280 additional galaxies. That is just phenomenal.
Okay, so we are in the Milky Way galaxy. We are one galaxy. I mean, the numbers of Heavenly Father's creations are they can't be counted.
Yep. Sand in the sea.
It's crazy.
And I mean, when you get a good look at the Milky Way, it's awesome.
Yeah.
And that's
like
just
when you're in total darkness.
Right. And when you think about it, the vastness of that, it just
think about 280 of those. Crazy.
Yeah. Amazing.
Many of the galaxies in this region seem to rotate in the same direction as the filament itself, far more frequently than would be expected from a random orientation. This pattern challenges existing models and indicates that large cosmic structures may shape galaxy rotation more powerfully or over longer periods of time than previously understood.
The researchers found that the galaxies on either side of the filament's spine are moving in opposite directions, suggesting that the entire structure is rotating. Using models of filament dynamics, they inferred the rotation velocity of 110 kilometers per second?
Per second, yep.
No way. That's crazy.
Yep.
And estimated the radius of the filament's dense central region at approximately 50 kiloparsecs. I don't know what that is, but it says it's about 163,000 light years. So
Well, we know that Han Solo did the Kessel run in 12 parsecs. We know that.
Okay. Okay.
Co-lead author Dr. Leela Jung, Department of Physics, University of Oxford, said, quote, what makes this structure exceptional is not just its size, but the combination of spin alignment and rotational motion. You can liken it to the teacups ride at a theme park. Oh, yeah, that's a good one. The teacups, right? Each galaxy is like a spinning teacup, but the whole platform, the cosmic filament, is rotating too. This dual motion gives us rare insight into how galaxies gain their spin from the larger structures they live in.
The filament appears to be a young, relatively undisturbed structure. Its large number of gas-rich galaxies and low internal motion, a so-called dynamically cold state, suggests it's still in an early stage of development.
It's crazy. It's crazy. I wonder if it's expanding and growing with, like dust particles banging into each other and creating planets and stars and galaxies.
Yeah, I don't
Since
know.
hydrogen
I'm getting sick to my stomach thinking about the teacups. So just
Since hydrogen is the raw material for star formation, galaxies that contain much hydrogen gas are actively gathering or retaining fuel to form stars. Studying these galaxies can therefore give a window into early or ongoing stages of galaxy evolution.
hydrogen-rich galaxies are also excellent tracers of gas flow along cosmic filaments. Because atomic hydrogen is more easily disturbed by motion, its presence helps reveal how gas is funneled through filaments into galaxies, offering clues about how angular momentum flows through the cosmic web to influence galaxy morphology, spin, and star formation. Okay.
The discovery could also inform future efforts to model intrinsic alignments of galaxies, a potential contaminant in upcoming weak lensing cosmology surveys with the European Space Agency's Euclid mission and the Vera C. Rubin Observatory in Chile.
The international team used data from South of Africa's Meerkat, MEERKAT,
It's an acronym.
radio telescope, one of the world's most powerful telescopes, comprising an array of 64 interlinked satellite dishes. This spinning filament was discovered using a deep survey of the sky called MIGHTEE, MIGHTEE, which is led by Professor of Astrophysics Matt Jarvis. I think we've talked about him before. Department of Physics, University of Oxford. This was combined with optical observations from the Dark Energy Spectroscopic Instrument and the Sloan Digital Sky Survey to reveal a cosmic filament exhibiting both coherent galaxy spin alignment and bulk rotation. So if you know what any of that stuff is, let us know.
So, fun fact: Sloan was the name of the girl in Bueller's Day Off. The girlfriend.
Oh yeah, yeah.
Oh.
Ferris Bueller. Yeah. And
I
what was
feel
the guy's name that played Ferris Bueller?
Matthew Broderick.
Matthew Broderick. Yep.
Yeah.
Okay.
Okay, folks. Thanks for joining us. We appreciate you joining us. Catch us this afternoon.
Yep. Take care, everyone. We'll see you in a few hours.